Perfect.
Right, over to you, Paul.
So, sorry about that. YouTube going crazy after playing the video. So apologies for that noise. Dennis, thanks for the introduction. My name is Paul Burke. I guess I've worked in the security industry for quite a few years now. And the objective of this session really is to get a discussion going between everybody participating. So I don't plan to spend very much time at all preaching to you about any particular technology, but the focus of this discussion really is to get some views about the different types of technology that can be used to address the problem of malware infiltrating organizations. And fundamentally, we see it as there's three choices: two pretty well-known ones and a new emerging one that is near and dear to Glasswall's heart. So for 30 years there has been traditional antivirus solutions, really pattern-based detection, looking for strings of bits, bytes that match certain patterns, and therefore triggering that represents some kind of malware. The second technology that is in quite common use now is network sandboxing, what some people call detonation chambers. This is where you would put any suspect file into a ring-fenced environment and you watch how it behaves and you see whether it does anything that you regard as bad or dangerous, and from that you make a decision about whether that is a piece of malware or a threat. And then the third technology that we're kind of adding to this, and we're trying to raise the profile on, is CDR, or content disarm and reconstruct. So rather than looking for the malware, what you do is you look through any file and you determine what is good and valid based on the standard of that file type, and you only retain that. You create new clean versions of the file only containing those pieces, and therefore you end up with a safe, low-risk file for use. So those are the three technologies, but I'm interested in getting everybody to share some opinions about those different technologies. So let me start by saying, how effective do we think each of those technologies are at stopping malware? What are the pros and cons of each? So does anybody want to offer some opinions about any one of those three technologies, about their level of efficacy? And I can pick on some people to try and get the conversation going if nobody jumps in. But what are people's views about, let's start with antivirus. It's been around the longest. How effective is that still in the current climate? Anybody want to offer some opinion on that?
I can share mine, since we've played a lot with different anti-malware vendors.
Mm-hmm.
By the way, I'm from OPSOP for everybody, in case, because we skipped the introduction part. We have, besides the CDR, we also have like multi-scanning functionality with roughly like 35 anti-malware vendors right now as part of our portfolio. So we have a lot of, let's say, we have this product available for like almost 15 years now. So we know a lot of like how we play with other anti-malware vendors and what's the detection ratio and so on. Even though we're not going to expose per vendor, we kind of like know where we're at. And the fact we invested heavily in CDR, that pretty much paints this picture, right? Like, is actually antivirus, or even like one antivirus is not enough, not to mention that even 30 of them are still not going to cover the entire story. What I would like to say for each of them, because again, I'm not allowed to complain about them anyway, but I don't plan to.
Well, remember, this is not about complaining, Georgia. This is really an observational session, right? So
yeah, I'm kidding. Don't worry. Like the entire idea is that each of them have their own unique way of detecting malware, right? And it's not just about signature, like signature-based detection. A lot of them invested in a lot more than just signatures. Most of them have some heuristics. Some of them actually have like AI machine learning embedded in the SDKs, or they have like dedicated machine learning engines and so on. And we've seen a lot of traction or like improvement in detection for some of these vendors. But at the end of the day, it's still not going to have like a 100% coverage. The fact that you can actually have, let's say, they support most of the file types and so on, especially like executables and binaries that CDR are not going to address, it's a big point. But at the same time, it's more about the fact that they have the intelligence of detection, but they're like very separate technology stack and expectations. And then there's also the discussion of like static versus dynamic analysis, right? For instance, what we play with the multi-scanner, it's the detection SDK, which is a static component. So we're gonna scan all those files and we can provide some results in milliseconds, hundreds of milliseconds, right? Even if some of them have some emulation engine in it, let's say. The fact that you need to provide in 50 milliseconds versus detonating a sandbox for 15 minutes, it's a huge difference, right? You can monitor the behavior or not. But at the same time, the same detection engine powers the endpoint security product. So even if it's on the endpoint, because whenever you're looking, and this is maybe one of the things I want to touch on when it comes to like CDR as a prevention tool versus the AV, right? You're gonna see AV comparatives, AV tests, all like testing labs that are providing reports like, hey, I know, McAfee is doing 99.9%, Kaspersky is 100%, the other one, machine learning, is doing this and that, right? At the end of the day, those detections are totally different than what you see on the gateway, if you want, right, in the static environment, because they have like a lot more intelligence on the endpoint, a lot more context what things are happening, but still it's bypassing those ones. So to a certain level, it's not a one-to-one comparison. Each of them serves a different purpose. That's all, maybe like the best way to put it.
That is interesting. Even if you have the same engine version and pattern version, you don't get the same detection rates for different use cases, whether it's on gateway or endpoint.
Again, it has like different context, right? It has like different visibility into like what's going on.
Right.
Sorry.
So you're saying
this is hi. This is Oren Voskin from Tessa Software. What I wanted to contribute. So first of all, when we're talking about in this forum about signature-based detection, first of all, we're talking, of course, about static file analysis. So like George mentioned, we're not leveraging any active behavioral-based endpoint detection. What I wanted to add on top of what George mentioned is the experience that we have with so-called next-generation detection technologies. I don't know what you guys out there have experienced, but we've evaluated several of those of the pretty well-known brands. They all perform very poorly, to almost to the point of ridicule, I would say, compared to a good batch of signature-based AVs. So I mean, first of all, of course, the file types they support are usually very limited. So MS Office, you know, either OLE or OXML, PDFs, you know, some PEs. But the if you take the static detection capabilities of your typical next-gen AV, I don't want to say it's worthless, but as a standalone product, we found they perform very, very poorly. What is interesting about them is the sort of overlap that George mentioned, that when you're combining different technologies, then you're already reaching a point of diminishing returns, where if you add the next-gen AV at this stage, then they usually can add a bit more information, like for a new mutation, compared to what a signature-based AV might have missed. And this is important, especially important with files or in scenarios that you just cannot disarm. You know, you cannot run the full reconstruction. I mean, of course, you know, binaries you cannot reconstruct, but also when there are scenarios that, according to policy, you're just not allowed to do as in-depth of a treatment to the file. And then it is useful to add whatever capability you can. But I think when, you know, I'll be wondering to hear the feedback here. But, you know, when you're sort of faced with, oh, we've got, I don't know, say, carbon black, okay? then I think it's important to communicate, with the potentials about what we're saying that these products usually do. And believe me, in the end, a properly, good professionals often agree with this type of feedback.
Okay, so you're advocating that traditional pattern-based is a pretty effective baseline for a lot of things. Can you, by talking about next-gen protection, are you really referring to CDR, or are you thinking about a broader set of technologies in that next-gen bucket?
So when I'm talking about, since the topic now is about the effectiveness of different types of detection-based technologies, then George talked about signature-based AVs, and I'm talking about AI-based, detection, AI-based static detection.
All right, got it. Okay.
So I'm not going into a phase of like next-gen CDR or something like that, but talking about the different arrays you may have to pre-filter files that you can determine to be malicious. So what I'm saying is that your base should be signature-based detection, and then you can add on top of that some next-gen. It adds some value, and I'll let you guys continue the discussion on the other technologies.
Yeah. Okay. I would just like to ask one question, if I can, Oren. Where you compare those things, how do you measure the efficacy? What tests do you use? How do you gather results? Because you say they perform poorly, so it'd be good to understand how you go about evaluating. Right.
So, there was a previous discussion about data sets. We have our own repository that our FRET R&D team builds. Some of them can actually be quite old also stuff, which is important in these days, since there's a lot of repackaging of threats. But simply, what we'd simply do is just try to download, just get a batch, even from VirusTotal, of stuff that are relatively new or stuff that are sort of, obscure, right? So my colleague here mentioned McAfee, Kaspersky, so it's big stuff that are a bit more obscure by what threats are detected, and run them through the different tools. But let's just give you an example. So if I prepared a data set that tries to mimic highly mutated threats, okay, say 1,000 files, right? Then what I would see is that a good batch of signature-based AVs will catch 60, or will catch around 600, which is pretty in line, with what we know of how signature-based AVs perform. And then what I would see in these results, that the next-gen AVs will catch 40. But usually those 40s are ones that were often missed by the signature-based AVs. So say they will add a delta of 30 additional hit rates.
Yeah, so you take your total hit rate.
Sorry?
Then you take the total hit rate of the two combined technologies to 630.
Right, exactly. So if I've taken a pretty well optimized set of signature-based AVs, like George said, which is very important, then you try to it's like, just diminishing returns. You try to find whatever you can to add a little bit more, and next-gen AVs can add a little bit more. But from our experience, not much more than that.
Got it. Okay.
Two quick questions, if you don't mind, to clarify. First, when you said like 60 and 600 versus 30, the total is 630 or the total is 90? It's like those percentages or number of files? As you mentioned,
right, so again, if I look at this batch, that we prepared of say 1,000 malicious files, then
if you take a good batch of signature-based AVs, they will catch 600, so 600. And if I add on top of that the next-gen AVs, they'll add several dozens, I would say.
Okay. Okay. And very important, is this pretty much running them still in static analysis, right? It's not like opening them on an endpoint that's running that next-gen AV.
No. So this would be a this would be a static file analysis.
Yeah.
Okay.
Yeah, I mean, once it's in the realm of EDR, a more dynamic thing. That's a different topic, because usually CDR is somewhere on the perimeter before that file will reach the active scanning or whatever you can call it.
Right. I'm not an advocate, let's say, for next gen necessarily, but what I want to say is that, again, next gen got a lot of traction through the endpoint detection and pretty much endpoint detection response that was originally more like in the next gen and so on. So I think the fact that they kind of try to get some intelligence out of that and create an SDK or create a detection mechanism in static environment, that's slightly different, right? It's the other way. It's the other way around, right? Like, instead of having a detection engine and that goes in the endpoint, they kind of rip it apart from the endpoint and create a detection. So their focus, it's still detection in an endpoint, not necessarily in a static environment. I would say that, I don't know, again, I'm not advocating for them or I'm siding with anyone, but it's a matter of the test needs to need to reflect their capabilities as well, right? And of course, you have technologies that have been for 20 years and signature detection and so on, some of the vendors, versus something was built in the last year or so on the static analysis for the next-gen AVs. We are also part of anti-malware testing standards organization, and I've had the pleasure to go to quite a few of those meetings. And I can tell you for sure, whenever it comes to testing, vendors versus test organizations, there's a lot of things that are trying to pretty much that organization is trying to regulate on how tests are being made to make it sure that it's legit and makes sense for each of the vendors. It's an equal way of distributing, especially qualifying the samples and so on. So there's a lot of discussions based on that one. It's not an easy process. I'm going to put 1,000 files together and I'm going to send to. So that's the point. But again, those two are totally different than the static environment we're talking about.
Yeah. And in that static environment, what are your views about, obviously the static solutions are very reliant on the latest patterns and details, assuming that the test sets are quite modern, up-to-date files. How easy and effective are the pattern update deployment models now with the AV vendors?
I can share my view on that story, right? So I think first, I have the benefit that we have not just the multi-scanner as part of our portfolio, but we also have that relationship with all the vendors for a while now, and I'm personally involved in those relationships anyway, so I can share a little bit more on that one. But we also have a malware sharing program, right? So we exchange malware samples that we're seeing on Manifender Cloud, which is our SaaS offering on that one, right?
Yeah.
But we're also sharing with what we see with different partners, malware researchers, or different organizations and so on.
I understand that there's a lot of collaboration. I mean, I previously have worked for Trend Micro and AVG, so I kind of know. Yeah. But you're sharing the samples, then there's still the job of figuring out what that sample does, creating the pattern for it, verifying it, making sure you can resolve it, quarantine all the pieces before you can roll it out. And it's still, given the very rapid rate of new malware variants, the effectiveness of static analysis really comes down to how effectively can you continue to get very rapid deployment of new patterns. At least that's my view, right?
Yeah, it's first first getting detection or getting the sample, write the signature for it, and then distribution, right? And we're trying to help on the sample side. I'll give you that, but at the same time, it's a matter of can be even weeks. We saw for a big outbreak that took even 2 weeks for like 2 of the top tier vendors to actually respond to, right? And that's huge from my perspective. In general, it's kind of like a day, maximum 2, but can happen to actually be even weeks, right? And again, we have the benefit of, I don't know, some of them we kind of like rescanning them and so on. Sorry, Jonathan, yes?
Yeah, I was just kind of wondering, where do heuristics come into this sort of taxonomy of security products, which we sort of attempt to analyze, behavior rather than looking for specific signatures?
Well, so again, most of this SDKs that we use, at least, right? A big part of it, it's also have heuristics enabled. Now, again, heuristics to some level help, but a lot of, especially in production, let me put it this way, in production, a lot of people consider heuristics a big source of false positive to some level, right? So that's already kind of like a concern. And second, it's also the fact that it's still a very short time, right? Like they're trying to respond in a very short period of time. It's not going to be able to run the entire code, have more context and so on. So heuristics will help, but it's not going to take it from like a 30-40% detection to like 90%, right?
Yeah, I mean, at one point they seem to be held out as like, the great white hope against 0 days, but people seem to be talking about it less. So I was kind of interested what the perspective was on that.
Yeah, I mean,
I think I shared.
Yeah, go ahead, George.
I shared in the previous call this morning where I mentioned like one of our bank customer was looking at disabling archive extraction for productivity files, right? And only based on that, again, we run a test like 5,000 samples. And if you run it with them like a docx versus open them as an archive, it was like a 30% difference between the detection, right? Which is huge. And the bank customer pitch was pretty much like, hey, this is, I know, these are like very reputable brands. I expect for them to know how to handle docx by themselves. I don't want for us to like also open them as an archive and so on, right?
Yeah.
And then that changed their mind, let's say.
Yeah. Yeah, I mean, anecdotally, I've talked to some people. When you look at dynamic analysis heuristics, I tend to kind of lump all those as the kind of things you do inside network sandboxes to isolate them from, real operating systems. There's a couple of things really. One is how long are you willing to wait for any sample that goes into those analysis before you get a result? Going back when I was at AVG, which is probably 8 years or more ago, a lot of those companies were coming out saying we can detect all these things and we detect them days and days and days in advance of static analysis. I'm not sure that that's still the kind of delta that you see. I think that delta has been reduced. Plus, as you indicated, George, a lot of those traditional AV vendors have bundled together some of that heuristics with traditional static analysis to try and increase their detection rates. And then the other issue that comes up quite a lot is I suppose, two sides of the same coin, which is how often can those dynamic analysis engines be fooled by potential malware detecting that it's in a sandbox and just not triggering, and how often is it fooled because the rule set it has, it looks at a particular file or application that looks like it's doing dangerous things, quarantines it, but actually it's a false positive. And I've heard various things about the rates of those, but there seems to be a reasonable degree of frustration from people on network sandboxes as to things like the rates on those two things.
Yeah, particularly amusing when they pick on an operating system component or a vital part of an application as a potential. Yeah,
that's always fun.
Yeah, you kind of have to draw a view of, what represents bad behavior for any application in your sandbox, right?
Yeah.
My personal take on this one first, sandboxes are for more analysis. They're not for detection, definitely not for prevention, right? It's pure analysis, try to understand the behavior, try to see what's going on there and so on. Second, it's very hard for you to build a lab in which you're gonna replicate entirely your enterprise distribution of endpoints, right? Like there are like multiple different operating systems. Most probably the big organization the bigger, I don't know, distribution of applications and things like that, right? So regardless if you tested on, I don't know, Windows 8 with Acrobat Reader 12, whatever, if you're running Windows 10 with Acrobat Reader 14 or something like that on the endpoint, right? So there's always kind of like this kind of difference or gap, right? At the end of the day, even in malware analysis labs, is one of our biggest focus in the past, like one of our main user personas in the past were malware analysis, right? We have like a lot of certain organizations on our customers. So I had a chance to talk to them. None of them rely only on Sandbox to build an entire malware analysis lab. More than that, most of them have like multiple sandboxes in their environment, right? So from that perspective, not even that one is covering 100% of like what you can achieve with the sandbox. So again, you can detonate, you can observe the behavior. There's a lot of topics, a lot of discussion about malware armoring, evading sandboxes and so on, right? Again, that's why you have like kind of IDA Pro. That's why you have like even genomes and DNA, malware DNA check, I don't know, similarities, things like that, right? Because you need to like try to, I don't know, at least push you in the direction to know what to search for and so on. It's not just like I'm detonating in a sandbox, I know the result done. This is Trojan 1, 2, 3 done. Next.
Yeah. The other thing that's relevant to that, I mean, I've certainly had conversations with Gartner analysts in the not too distant past, and if you look at their recommendations on something like a secure email gateway stack, they do recommend the use of things like traditional antivirus as one of the protection layers, but they tend to talk about an advanced threat protection layer, and they usually lump one of two technologies in there, one being CDR and the other one being network sandboxing, which kind of is contrary to one of your observations there about those kind of sandboxes are good for malware analysis, but the issue in an operational sense, and I've certainly, heard a couple of our customers, they use sandboxes in an operational sense, but they have kind of strange operational processes where they will, let's say an attachment comes in, they will let that attachment on the email flow to the user's inbox. At the same time, they'll put it in the sandbox, and 5 minutes later, when the sandbox says, "Oh, that's dangerous," they then attempt to recover it from inboxes where it's gone to. So it's kind of a high risk strategy to do that, given.
Immediate reaction was that sounds insane.
Yeah, but operationally, I've heard a couple of companies say that's what they're doing, and I'm sure there are a lot more.
So I have a couple of friends at some of the big companies that are doing, like, there's all of them, let's say, one more or less have some dynamic analysis component, almost all of them, let's say, have like a sandbox component to it, right? And I talked to like some of my friends, and one of them was like, yeah, what we do is pretty much, I'm gonna, let's say, let it through. I have that sacrifice go. The moment one user clicks the link or opens the attachments, that's when I'm going to detonate, because it's too expensive for me, for maybe like millions of users, to detonate all their attachments, URLs and so on, right? And that is a usability is perfect from the end user perspective, because you don't need to wait for anything, right? But it's a huge risk, right? Yes. So someone will definitely gonna go, I don't know, go down at some point, right? On the other side, my other friend was like, well, we're doing slightly different, where you click the link and you can have like a spinner telling you need to wait for the analysis to finish. And people after like 10 minutes, they close it, like there's a time of 10 minutes, and they're like super unhappy. We're losing customers on that one, right? So there's always kind of like this back and forth. And again, I think the end user experience is the one that should prevail, right? But not in the idea of like increasing the risk. This is where CDR comes into play. And to your point with Gartner recommendation and so on, Gartner, and again, analysts in general, let's say, recommend based on what they see in the market that is efficient, right? Or like offerings in the market, right? So let's say, regardless if it's going to come with OPSOT, Glasswall, whoever, with like a better solution that's going to address a problem. But if like, I don't know, 90% of the market is being addressed by, I don't know, Proofpoint and a couple more vendors, they're going to offer what they see that most of the market is using. Again, back to the previous discussion we had this morning with what the peers are recommending, what they're considering a good solution for them, right? So they are pushing technologies that are more, I know, it's not necessarily that they're going to be early adopters, because the technology has been around, but let's say more like emerging technologies, right? They're going to push that one. But at the end, they will recommend what's existing on the market and has been successful for a while.
Yeah, so I agree, with George and Paul, what you both said. I've worked extensively with our Gartner analyst, and I just posted a quote from them from the hype cycle for threat testing technologies, that they have a pretty long section there about CDR. So, there's quite a consensus today, at least in the Gartner analyst community, about deficiencies that there are with sandboxing and an increasing recommendation. In multiple recent Gartner analyst papers to augment analysis, to augment security using CDR, especially for attachments in emails. And in fact, in one of the recent articles they had about Office 365, I think this is like the second time this year that they recommended to use CDR as an augmentation for Office 365 ATP. So there's quite a consensus around that.
Yeah, but they've always kind of, as you say, as I think, I forget who mentioned it now, because sandboxing is widely used, they're just saying, well, that's what their customers are using, so it's almost become a recommendation. Whereas my observation is that doesn't seem a very appropriate technology for handling, email going through a secure email gateway stack, because of the latency it introduces. It frustrates the users. So I absolutely agree with the note you put in the chat box there, that the performance or the time taken by CDR is an important factor. But I do think there's a place for both to some extent, because certainly the function of CDR can be slowed down with very large files, whereas there isn't really much increase in time, even with very large files, of putting those in the sandbox. So I think you reach a point where there's a small proportion of files that are easier and more straightforward to manage through a network sandbox rather than through CDR. And certainly we've done.
Yeah, I tend to agree with that. I mean, there are obviously use cases like I mentioned in the previous discussion, that you cannot disarm files. If you have to keep some active content, or the files are structured so you cannot make any changes. So definitely are use cases. But I think one of the colleagues here previously said that we're seeing among our customers more and more of a switch for sandboxing as a malware research tool, and it's being used less, as a security layer. And if it is, usually there's just so many techniques today for shortcuts to actually detonate the file in the sandbox. So it will send a file to multi-scanning, will blacklist, whitelist files, etc. And only in the last resort will actually go into dynamic analysis. So just like an impression that sandboxes are working much, much faster today, but it's actually that much less files are being detonated.
Yeah.
So can I ask a question? On the topic of, from a usability point of view, right, which is clearly one of the areas that is very important. Have you seen cases where, one of the advantage of the CDR technology is the fact that in a lot of cases, we can actually give the file to the user? And I go back to several cases when I was handling, malware incidents and virus and things that were sent to people that they needed the data. And one of the challenges that we had from a usability point of view is not only will take the laptop away, which of course, if you're a finance person and you have tons of spreadsheets and documents in there, is a massive problem. There was lots of cases where we literally have files, especially spreadsheets and other documents that they needed, right? And basically, we were able, we detected, and some cases were only DDR who picked it up or other situations. But the fact that the CDR technology can actually give a usable file, or as close as you can of the original file to the user, even when he started malicious, have you seen cases where that makes a big difference?
Well, if I understood the question or comment correctly, again, I just have a bit of hearing loss, so if you can also type it. So I think this is more of a, like a use case thing. So in scenarios where they say, oh, my accounting needs the macros in their Excel, if this is what you're asking, then yeah, then give it to them. But at least the solution should be able to enforce policy to reduce risk. So only the IT department, maybe only specific users in the IT department will have the CDR engine configured in a way that will enable that active content, and everybody else should be restricted. Same thing like for an IT department, if you allow binaries inside, so you allow binaries only for specific people. And the other thing, that I sort of use to counter this is that, look, folks, usually all these files of all of the that active content should really be only stuff that you have inside of an organization. And if you ask them honestly, how much do you receive of that coming from the outside world, you understand that it's really limited to only very, very specific use cases inside of the organization. And in that scenario, go ahead and use a sandbox to detonate those files. So I hope I understood. I heard the comment, question correctly.
I was approaching more from the usability capability that we, CDR has to actually give a file that started with malware to the user in a safe way.
Let me, I would think about asking the question in a different way, maybe to context, and Dennis, tell me if I'm changing the context. But if you thought about static analysis or even sandboxing, dynamic analysis, the result is you quarantine the entire file and you don't let the user have the file because it's dangerous. The question is, to me, is in what situations does that become too much of a frustration for the users who are being restricted from those files? And therefore, is the better answer to apply CDR that removes the risk from the file and delivers a clean, safe file, even if it's got some components removed?
Yep.
I can share based on my experience, let's say, or like our experience. In general, we don't, or like whenever we discuss with the prospect, there's always that question, like what happens if I need the original file, right? What we try to provide is kind of like the solution, like an end-to-end flow, if you want, not just like technology, right? So kind of like explain what's the process in our, with our solution and so on, kind of like makes sense. I don't think we had a lot of cases, to be honest, where they actually needed the original file. So that was, from usability perspective, that's a huge plus for us, right? Like, at least that's how you perceive it, right? So they're consuming always the sanitized file. There were like a few edge cases, let's say, when they cannot consume the sanitized file, again, digitally signed PDF, things like that, right? However, if it's actually needed, we do have the audit trail to understand what was sanitized. We give the option if they want to like throw in a sandbox and so on. But at the end of the day, to the original question, like if the file was originally malicious, no, our advice is like never consume. Even if I'm able to sanitize, what's the point, right? Yeah. It's a matter of like, if you know that the file came from George and it was a malicious file, you should go and check out what happened there. Like the fact that Paul is gonna get a sanitized file, it's gonna consume it. Usually, even if you have, let's say, if it's a malicious file with, let's say like a ransom or something, you can exploit it, something, it's gonna say, okay, like content, it's scrambled, you need to enable macros to see the content, that kind of BS, right? Like the content is useless anyway. So even if you sanitize that file, like, there's not gonna be anything on the end user side that's gonna be relevant necessarily, right? Now, if it was like a legit file that got infected somehow and so on, like, and something was embedded in that one, still, it is a malicious file. The fact that I share something malicious with you, for me, it's still an alert that should be taken into consideration. And the fact you can sanitize that file and you can consume the sanitized file, that can happen, maybe a different files will be shared in the future and so on. So that alert should be handled anyway, from my perspective. And to some level, again, it's a matter of, maybe for us, it's a bit different because we're also pushing the multi-scanning as part of like detection before you actually sanitize the file. But for me, the fact you have an alert knowing that malicious file is coming your way, that's a huge advantage, right? Because you know that people are trying to send you malicious files, people are trying to bypass your systems and things like that, right? So you have that intelligence. From my perspective, visibility is as much as important as reducing the risk.
All right.
And do you get actually just on that visibility? And so you're saying that because you guys run, you know, also the static and, you know, all those engines in place, you're getting a lot of good metadata and a lot of good threat intelligence from those non-CDR engines than from the CDR engine.
Well, it's kind of like a complementary solution, right? Like it's not like a one or the other necessarily. Yes, the entire idea of like CDR doesn't run detection, right? Like even if let's say you can deploy 30 anti-malware vendors and none of them detects anything, we still recommend to sanitize the file. It's not like I'm saying that, hey, sanitize the only one, like one or two files or like one or two engines, it's flagging it, or like if it's more than 10, just block it because it's malicious. That's not necessarily the pitch, right? But again, to some level, for me at least, provides that visibility, at least for like, I don't know, known bad for sure. Like whatever it's like a non-malicious file, getting detection from all those provides one of the biggest blacklists if you want it to work, right? Because relying on hashes for detection, especially like in documents, it's useless, right? Because you can easily repackage something and so on. So it's a matter of the fact you can always have like a 100% hit ratio if you want, because we're able to analyze everything in place, right? So for me, there is a selling point on that one, and then CDR comes into play, and we have examples on Defender Cloud where we got samples where none of the AVs detected it at the beginning, and then they started picking up, and like 2 weeks later, like half of them are detecting it or something like that, right? So that's where CDR comes to play, shows the value, right? Even though none of them detected it, you're still gonna consume the same base copy.
Yeah, cool, thanks.
All right. Another
Can
question.
I ask a question?
Go ahead, Petra.
Yeah. Hi. So I have one question and something to show you as like something to say about CDR. So the question is, if you would to write a research paper on CDR, how would you approach it? Like, what would be your method? I'm just asking like everyone here. It's a quick share. 1 second. Well, I'm asking if you mind, but I'm going to share it anyway. So
Yeah.
right. So
go for it, Petra.
Do you all see my screen?
Yeah, we do.
Okay, so quickly, this is just something that I've done in Glasswall. I'm doing with machine learning, which is kind of a way to approach also CDR and proving its efficiency and correlation, actually not just removal, but potentially even detecting it. But that's kind of all correlated to one another. But basically, I took a set of good files and I took a set of bad files, and I took their analysis. I ran it through them.
Hey, Petra.
Basically, it's preliminary, I have to say. But I ran it through some machine learning algorithms, and really, really good result. So, yeah.
We really want to be able to hear you, but we actually can't very well. There's a lot of distortion.
Hello, can you hear me?
Yeah, getting a lot of distortion on your audio, Petra. Oh, we lost her.
Sorry, Petra, it's probably when you go to video. Can you share just quickly the link with Paul and he can just do the slides?
Yeah, looks like Petra dropped off.
Yeah, because we already got the slides. So if you, all right, I think she dropped. Maybe she's going to the garden. See if she has better bandwidth.
Let's see if it connects up, and we can pick that one up again. I mean, I think on a little bit of a similar vein, you know, one of the things that.
Hi.
Oh, hi, Petra.
Hi, can you hear me now?
Yeah, you sound okay. You want to have another shot?
Okay. I'll try again. Let's see what happens when I share my
No, your audio is breaking up, Petra.
That's what I was saying, Petra. Can you send?
Okay.
Can you send a link?
What's the last thing you heard from me?
No, Petra. The problem is you can't share your screen. Can you send the link? Because I know you published this. Can you send the link to Paul?
Yeah,
and you
put
can
the
share
link
the
on the
screen.
chat and I'll open it for you.
Oh no. Okay.
Right, stop sharing your screen, Petra.
Stop sharing your screen.
Yeah.
Better.
What I just I can try.
Petra, can you hear me?
Yeah.
Can you just stop sharing your screen?
Yeah. Yeah. We'll do 1 second.
Okay. Okay, and if that's a shared file, Petra, oh, we've lost her again. We'll give her a sec to reconnect.
Yeah, it's really cool what she's doing because she's actually doing a machine learning project. Paul, I got the link here. Let me give it to you.
Okay.
So
put it on the chat.
Yep, put it on the chat. So see the power of sharing stuff. So it's actually on slide share. So yeah, there you go. And so you can get it from there. And actually it's also on slide share. So yeah, you got the link to slide share there. If you want to present from slide share, you can present directly from Twitter. You got it, Paul?
Let's have a look here.
Yeah, so what Petra is going to cover a bit is the idea of using the data that we get from the CDR engines to build machine learning algorithms that can then be used to make a prediction where a file is good or bad.
Okay, let me just. Okay, Petra, are you back with us yet?
Not yet.
Give her a sec.
So actually, while she connects, I had another question, which is related to the effectiveness of the new generation sort of EDR and probably AVs, because I think actually AVs should be merging with EDR, right? Because that's the next generation. But the ones that have cloud-based sort of connections, i.e. they also use real-time feeds from cloud-based services. Have you guys seen good effectiveness on that?
Again, like, is this static or is actually, I don't know, on the
no, dynamic, right?
So
so this is dynamic, right? You know, yeah. Look, I actually think that when we call antivirus, right, like literally, you know, that whole field should almost merge with EDR, right? Because, you know, AV that, you know, if he runs on the client, he should be also starting to look both static and dynamic, right?
Yeah.
Because
well, I think
or else if,
the,
yeah, go on.
sorry, go ahead. I think the term now it's EPP, endpoint protection platforms, right?
Yeah.
They kind of like merge those two into that EPP concept.
Yeah.
Well, I think, I mean, definitely they improved a lot in the last, I know, couple of years. EPPs in general, I'm not talking like traditional or next gen or AI only and so on. And to a certain level, again, there are a lot of technologies, even vendors that say like antivirus is dead and so on. They went and like licensed AV SDKs and so on, right? So there is a need, pretty much back to the point like even Garn asked for it. So to a certain level, even like next gen AVs, some of them are using in the backend in their cloud and so on, some traditional AVs as well for detection. So sooner or later, it was like a normal, like natural way to merge those two into like one EVP market, if you want. Now, again, from my perspective, whatever happens on the endpoint, it's a little bit late, right? If you allow for a malicious file to reach the endpoint, it's, I don't know, that's the king's guard in the castle. It's not the entire army that should prevent, right, the invasion. So even if they're getting better, at the end of the day, they will, like a threat actor will do his best to like find ways to like bypass the system. And we had examples and on our cloud solution, I'm pretty sure that like other multi-scanner solutions or even people are buying the source and putting on the endpoint where we had threat actors trying to like refine their packaging of the malicious payload by scanning them until they made sure that the big vendors are not flagging them and so on, right? So that's what I'm saying, that even though they got better, threat actors will spend the time in that reconnaissance step to understand a bit better their environment, and they will try to find ways to like bypass those systems if it's just relying on detection.
Yeah, this is the build higher walls and they'll bring longer ladders, right?
Yeah.
Okay, doesn't look like Petra joined us again, Dennis. Do you want to talk to this her slide set?
Yeah, sure. Yep. So if you go there, go to the next slides. Yeah. So basically, she's taking classical machine learning algorithms. We're actually using Jupyter notebooks and sort of with pandas, as their Python API, and to kind of try to process the data. So if you go to the next one, the question is that we're trying to answer is can we use the sort of analysis report after the CDR to be used for malware detection? So so this is, which is an interesting twist, because initially the idea was that we don't do or CDR doesn't look for badness. But one of the questions that we always get asked is, what about the stuff that you drop, or what about the information that you get from the files? And the reality is that based on the data that we extract from the files, there is quite a lot of information that can be measured from it, right? There's quite a lot of analysis that we can do. So the logic here was, the question was, can we do that, right? So if you go to the next one, so what she kind of did was she fed a number of files that we know were malicious to the engine, and a bunch of files that we know were good. And then sort of, basically the idea was to teach the engine to say, hey, this is kind of what each of the sets look like. And then if you go to the next one, it kind of shows the, some of the analysis she was doing. And I'm not going to do this justice because she actually knows a lot more about this than I do, of the different algorithms and the recall sort of ability to detect the malicious file. So the point of this, if you go to the next one, is that when you look at all the different data points that you extract and the different features that we detect, you go to the next one. The logic was to determine which algorithm was better. So I think the random forest, if you look at the precision, if I believe that's the number that matters, and the accuracy, that column there is the one that we're looking for. And then if you look at on the right hand side, you can see that the KNN algorithm was actually much worse, right? So if you go to the next one, then what you've got is, so this basically line here is that you got the multiple algorithms, and the kind of the green one is that random forest one, which provides the biggest sort of definition of success, because it was able to correctly pinpoint basically when you deliver the next file, how likely you believe is actually to be a malicious file. So the red one failed, didn't do very well, but you can see that the closer you are to one, the closer you are to actually a true positive. So what the cool of this is that we're able to, for example, take a file that we never saw before, and based on just almost the teachings that were given to the machine learning algorithm of a large number of non-malicious files, get a rating of between 80% or 0.8 and 0.7 and 0.9 that tells us that file is potentially a problem. Yeah, I think that's it. Yeah, go next one. So yeah, so next areas is just get more data, try different algorithms. And this is something, again, we're happy to collaborate. And I think it would be interesting to see, how to create some of these data sets and how to use, machine learning for this. And I kind of know that the question that Petra was going to go with this is, is this a valid, machine, sort of CDR sort of research paper? And if not, what other topics?
Hi, can you hear me?
Oh, here you are.
Yeah, my laptop stopped working now, as like everything had to go wrong. So I'm on my phone right now.
Okay, well, we got your slides up, Petra, and we're on slide 9.
I hope I did it justice.
Talking to the work you've done, so
okay.
I'm quite happy to kind of flip between the slides if you want to talk about any specific.
Yeah, if you just go a little bit back, and I don't want to repeat myself too much, but just a few more slides back to the logistic regression.
Yep.
Yeah, so as I said,
actually, Petra, when you when you were saying it, we didn't hear you at all. We just heard a brief overview by Dennis, but we didn't actually hear anything that you actually said about it.
Okay. So, well, basically what I was trying to say is I took a data set of malicious and non-malicious files, and I took their post, CDR analysis, and what I did is I ran it through some machine learning algorithms just to see if just based on the analysis, the machine learning algorithms will spit out whether these files were malicious or not. And I got quite decent results. Now, these are just preliminary results right now. I still need to get a bigger data set to get even more, probably better results. But so far, just by using some simple algorithms like logistic regression, support vector machines, random forest. Now, these are very classical algorithms, and I already got like a recall of 0.9, which is quite good, which means that the algorithm is very good at detecting malicious files. And that basically kind of goes back to CDR, because it proves that there are some things that, in the issues that CDR found that actually show that the file was malicious or not. So if you go a little bit more further into the slides, maybe, yeah, so this one. So this one is actually plotted coefficients. So it actually shows how much each issue range had, like how important it is for the algorithm to recognize whether it's malicious or not. And you can clearly see that there are some issues that CDR has recognized, and that, directly correlates to the maliciousness of the file. And if you go another slide, and yeah, so these are a bit more random forest, k-nearest neighbors. K-nearest neighbors didn't perform well, but it never does on these kind of data sets. And if you go one more, please. Yeah, so this is kind of showing what we call the Roc Curve. And, when we have unbalanced data sets like here, where we have more malicious files and less good files, we rather look at the Roc Curve than the actual numbers. And you can see that the Roc Curve is quite good, because the more the up and the left it goes, the better your algorithm is. So these are kind of indirect, basically, confirmations of the efficiency of CDR, because it finds these issues that the CDR found, and it finds a direct correlation with the maliciousness of the file itself. Now, there is more research to be done here, definitely, and I need a bigger data set, and I'm going to apply some more sophisticated algorithms as well. But just by looking at these preliminary results, you can see that, you can actually find some research. You can actually do some research to kind of link CDR to actually just clearing malicious files, which we all know it does, but it's good to have it on kind of pen and paper. Also, I just wanted to ask, I don't know if anyone heard my question about, like, how would anyone here otherwise, not just with machine learning, or just otherwise approach researching CDR?
I can answer that.
Yeah.
So to some level, even though I'm not sure how much I'm allowed to disclose or not, or I'm pretty sure how I'm not really allowed to disclose, we've done a similar exercise. I think one of the ventures that we had like a way bigger data set. I think for the development was something like 300,000 files, something like that, and I think 1.5 million for when we run the actual test to see the final numbers and so on. We went with I believe random forest, to be honest. But what I want to say, what I intend on that one is to see if I can attach a risk, more or less, let's call it a risk, but like a risk score to the embedded objects, right? The problem that I see in general is that this is going to be very skewed. And first, depends a lot on your data set, right? But at the same time, let's say most of the malicious, I don't know, drivers, let's say in Office documents in Excel and docx are macros, right? So out of, let's say, I don't know, 300,000 files that are malicious, 209,000 of them are macros, right? That's going to skew the result, and it's going to attach like a smaller risk to maybe something like, I don't know, an embedded whatever script, all the objects, something, I don't know, there, right? And that's kind of one says that it's a matter of like, okay, how we can ensure that what we're training is kind of like a one-to-one comparison. And again, even like exploit kits for one particular thing, right? Like there's a document that was exploiting the Outlook preview mode, for instance, right? That's not something that this model is going to give him like a large score, because no other things were kind of like named that way if most of them are actually using macros. That was like one of the points, right?
Yeah, it's true. But then you can do a lot of things kind of with the algorithm itself to kind of, you know, to try and make up for these facts that it can be skewed. So you can mess with the parameters, and I still am investigating all these things, but you know, there is a lot of things. But I'm wondering, why is it you're saying you're not allowed to, you're not sure if you're allowed to say, but why is these things are not getting published? Like I'm doing, this is going to be my dissertation, and I'm going to, like, you know, I'm working to make it like a scientific paper, but I'm just wondering, like, why are people not coming out with this? I mean, how it...
This was built as like a functionality in the product. It's not yet available, let me put it this way, right? And there's more work to be done on that one. So that's why we don't have anything on it publicly available. That's why I'm saying that in general, I don't expose that, especially this is going to go public and so on. So I can expose like timelines, things like that. That's
sure.
Again, I don't have any problem like discussing on the technology side, maybe like even off topic of something like that, and bring maybe some of the engineers on that one. But this is just like kind of my comments based on the experience on that exercise.
Okay, all right. And anyone else has ever thought of like approaching CDR from like a scientific point of view to trying to like do some research on it or anything? I'm just wondering.
I was thinking about obviously the machine learning side of being able to set up and create test files to run against it. I was actually thinking that would be kind of interesting to see how you could interrelate the what you were doing with the creation of test files. But I mean, it would see whether or not that system could actually be tricked into either allowing malware through or blocking, I guess, too much. But it would be interesting to see how that played out if you had that set up as a type of loop on there, you know.
Interesting. Yeah, I would be keen to find out more about that.
I'd be interested in sort of seeing what this looks like if you were to pull out files that have sort of extensible features such as macros and sort of look at it from a perspective of threats that are not necessarily related to stuff like that, JavaScript, macros, etc. So I think you'd probably get a more interesting, you'll get interesting results at that point. I'm very curious to know what that would actually look like, because as George points out, I actually feel that because of stuff like that, macros, etc., the results would be pretty skewed.
But this is, to be fair, this is actually still without the macros. This is still like these preliminary results are without me putting it all in. So I need to expand my data set, and this is just very, very preliminary where I just took the issues. So so the sanitization part hasn't even come into place here, which I'm planning to add.
Okay.
So maybe this will, adding sanitization will actually kind of confuse my algorithm. It will be very interesting to see what it was just with the issues like here, and what results will give when I add in the sanitization features as well.
So I mean I like that line of thought to see what the results will be post sanitization, because then what you're doing is looking for features that can indicate the maliciousness of a file, by removing the malicious components, which makes sense to me because hackers are often lazy and they'll use the same Korean Word document or the same template, deliver lots of different malware mutations in it, but use the same PDF document over and over again.
So almost fingerprinting the structure of the file, essentially.
Exactly, yeah. So fingerprinting on the file, not that will be relatively consistent, where the malware itself might be highly mutated.
Okay, so saying that, like, let's say they reuse or like they buy for like $30 an exploit kit and they package it in a new file and so on. Because from my perspective, relying on, like, let's say the fingerprint, the hash of a file, and just block on that in documents, it's not reliable, because that's like the easiest one that you can actually craft, right? Or like slightly modify and change the hash. When it comes to like,
sorry, continue.
Yeah. Okay. What I want to say is that if we're looking at how this is going to look like after sanitization, well, again, I don't know exactly what your I don't know, feature extraction, like what you're looking at, what features you're looking in the files and so on, right? But then if the sanitization process will remove most of those functionalities, this is going to get even more skewed, right? It's going to look like, yes, all the files that don't have, I know, let's say, even though you said you're not using macros, all the files that are not using macros are safe to consume. It's going to be a result something like that, right? Like all the files are not using macros, hyperlinks, all the objects, whatever, activities controlled and so on are safe to consume, right? But that's not necessarily the message you want to send across, right? Or the fact that, yes, after the sanitization process, there is still some risk attached to those files because there are a couple of still features in that one. That might be, again, more to like either false positives or things that need to be improved on the sanitization process, maybe. I don't know.
I guess what you were saying, Petra, is that you actually haven't looked at those specific items. You haven't looked at sort of the macros, the JavaScript. So you're looking at the issues in a sense where the files were not non-compliant to a specification. So there were corruptions and we couldn't reconstruct that document. So you're looking at that, and from that perspective, I think that this is actually quite promising.
Exactly, because I actually, like, you're right. Like, I was hoping that the macros and all that will add some value once I put that as a feature as well. Because, as I said, I'm still playing with features, so I haven't added them yet. But maybe, yes, maybe my algorithm is better right now than it would be with the macros and all that. But yeah, actually, that's true. So we'll see how it goes. So I think it'll be interesting to find out because, you know, this is without any of that. So. And it's already giving some promising results. And this is just a small data set, so I need to give it much more files, and then it will be obviously much smarter than it is right now.
So with what you've got, essentially what you're saying is you could actually predict attacks in the nature of sort of buffer overflows, etc., because you're not actually considering the sort of extensible feature aspect of it.
Yeah. Yeah,
cool.
So yeah, I think it will be interesting. It will be interesting to find out. And as I said, it's my dissertation, so I'm planning to publish my results and all of that. So it will be very cool. I hope so. Well, even if it isn't, it's an experiment that's kind of it's good to think about, and maybe someone else can also take it up and do it even better than me. So yeah, it will be interesting.
I was thinking about like the sample generation thing. I just dropped something under the chat there. First, I accidentally sent it to just you, Petra, but then I put it on there for last time. It's for being able to develop samples through an adversarial network to basically test for malware analysis. I just thought it was kind of interesting because if you, and that's kind of what I was saying, if you could, it would be interesting to see how much it kind of bent the rules, how much it like went along with, or, you know, changed what was happening or what it was doing away from what is expected, you know. If you set it up on kind of a adversarial network type loop through there. And the reason I think about that is because what you're doing, not random possibilities, but you're testing it for actually learning to create based on the you know, the algorithms that are put in. But I don't know, it's one of those things that just seems like it would really give some very interesting information. It seems like that would be a good way to produce a lot of samples as well and find out how efficiently, I mean, if you set it to actual, like we were talking about, not messing up the structural components of files, but changing what's in between that, and inserting different things in between there, kind of fuzzing those areas. It seems like it would really give you an opportunity to find out a lot of information, really push those boundaries and see what it could do. But if you set up that kind of system, it should be away from everything else, like it's slated.
Yeah, I think you're right. You could, like, if you use machine learning to kind of guide you in that way, then what you're saying, you could kind of create some interesting files. And yeah, I agree, because machine learning is good also for like explainability a lot of times. So like these, you know, sometimes these algorithms look like they just work magically, but actually, like, if you dig deeper, you can find a lot of these coefficients and you can find a lot of reasons why, and that just gives you a direction where to, you know, move forward from there. So yeah, I see what you mean.
Was there anything worth sharing on the screen about adversarial networks?
I mean, I'd have to look back at the actual article here. Okay, let's see.
But they're quite hard. Like to create, like, adversarial networks are quite advanced thing to do. I don't know. I'm sticking to classical machine learning for now.
I can see that, but what they were doing was they were taking deep detect net and RL attack net. The RL attack net was generating the malware samples that could bypass deep detect net. It's just interesting to see how they were able to do that.
Yeah, they're quite fascinating.
Yeah, I think the other thing that would be worth looking at, I know we'd have work to do, but we talked throughout different sessions in this conference about the ISGs, which really point to what are the exploitable threat elements of different document types. It would be interesting to correlate based on those to see what that did to predictability.
Yeah, I really like that, because I think the ISGs provide a level of context that sometimes, you know, will be harder. And I think with the ISGs, you know, as and if you're able to start to get metadata on which of those detection points connect to an ISG, then I think you can start to weight and provide weighting to which one is more important, which one's less important, and you get a much more three-dimension view of the data.
Yeah, absolutely. If you map it all to ISGs, then you can just basically see the coefficients of every every bit of it, and like it will be interesting to kind of find each one of their value.
So that's kind of like the direction we kind of went through. Like when I talked about like features that were defined, what we were looking for in the files and so on. What I would say again is a matter of like, it's very important not just to like properly define those features, let's say, but also to have like a legit, like a valid sample set, and like a pretty large one, right? Because even in the ISGs, if there are like 15 different components you sanitize in a complex file format, and 2 of them are the outliers, let's say, right? The ones that have cover like 90% of the threads, or like in your sample set covers like 90% of them, right? That's when again skew the results. So, and again, it's kind of like moving to a certain level in the detection mechanism anyway. Right?
Yeah.
So if you want, I know, traditional like or next gen AVs and so on with detection on productivity documents, to a certain level, it's their greenfield.
It sounds to me though like a lot of the research Petra is putting up here is really based on what we'd refer to as remediation items. So variances in the underlying structure of the files rather than what are those known active content high-risk payload elements. And that's a much more interesting thing to me, because a lot of those are done as a byproduct of embedding the content in or finding ways to bring dangerous content in. So they're not necessarily as high profile, but they could be a good breadcrumb trail to indicate risk in files.
Yeah.
I'll be honest, I think that running just a set of malware and running a set of the files data separately through there, honestly would be a good idea to run it through separately like that. And I think that making a decision about how to create or how to generate those sample sets is probably one of the things that I think should be worked for, so that you know what you're working with and you know how to adjust everything else. Because I mean, if you see what you're missing, you're going to know what you're missing. You know what I mean?
Yeah.
Yeah. And I also think now, because I have so many features with these issues, when I add the active content and the macros and the sanitization contents, I think the weight of it won't, like those features won't bring a lot of weight. So yes, they might tell the algorithm, look, this might be important too, but it's not going to skew it in such a big way, because already there's so many other features in this algorithm that the algorithm just won't kind of put a lot of weight in just that, but it will just take it as like an addition to the whole set, because there's so, like my data set has so many features based on these issues that I think it will be pretty hard to skew it with the addition of sanitization. And I think it might be just an addition rather than a skew, but as I said, it will be interesting to find out.
Yeah. Yeah, one of the other things that was on my mind was whether, I think, George, you mentioned exploit kits, whether there's a way of looking at the telltale signs of an exploit kit being used on a file. So if it impacts, a dozen structures in the file, does it leave enough of the footprint that you could say, yeah, that looks like it's got all the telltale footprints on a correlation analysis?
Yeah.
Yeah, and that could be massive, because if you start to fingerprint some of the patterns that you can only see on malicious files, you might have a very clear signature that might be very much easier to detect those kind of reuses, because I think the beauty of it is that I think once you start looking at the object model of the file, we don't have one hash, we have thousands, dozens of thousands of hashes if we need to, or even just structures that you can start to compare, and you can create all these mini graphs, right, inside of it, and abstraction layers that if you then model that, I think it will be interesting to see the correlation between those files.
Yeah.
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 Well, you're going to have a long PhD thesis to write.
Okay. Yeah, I can leave that for my PhD. I still have to do my master's first.
Great.
What is the timeline for this?
Yeah, I have to finish my master's in September.
I guess the other question, the question that maybe is good just to address a little bit is that, if we, for other, even PhD students or master or other, individuals that want to research on top of CDR, what are good topics to do research on top of it? So this is one, but what other good topics there are?
Yeah, that's a good question.
Anybody got any thoughts on that one?
Yeah, that's what
well, sorry. I already kind of shared what we were trying to do in that direction, let's say. One thing on add, and again, sorry if I missed that part at the beginning, that you're looking more not on the panel ISGs, let's say, if you want to call it that way, right now for this analysis. But when you're moving more towards the direction of fingerprinting the exploit kits or like the payloads and things like that, right? That kind of moves into the genomes and malware DNA, and there's a few players in that market already. Right? I mean, doesn't mean that there's not room for more, but I'm trying to say that there are I don't know, people already doing that. You should check them out to see how what they're doing. But to a certain level, the moment you go in that direction is slightly different user persona. Let me put it this way, right? That there's technologies usually consumed more like in malware analysis labs and malware analysis in general than actually on the gateway necessarily. If this is going to be something for more a decision process, right? Then it's slightly different direction.
Yeah. But I just wanted to come back to, I think Oren was talking about the effectiveness rates of static analysis using NextGen. And it struck me that the bar isn't very high for some of that predictability based on machine learning potentially. Do you think that's a fair comment, or do you think I'm being disingenuous to NextGen kind of static analysis?
I'm not allowed to confirm or deny the
Oh, maybe I should let Oren, are you still with us? Do you want to offer an opinion on that one?
So Paul, was that a question or?
Yeah, I was going back to your observations where you were talking about, I think it was you that was talking about test sets, and you were saying, you get 1,000 files, traditional static analysis, maybe you will identify 600. You might get next-gen static analysis, which I got the impression was based on AI machine learning techniques, might identify 40 or so. Which 30 would be unique, not detected by this. That doesn't sound like a massive needle mover. And I'm just trying to get a sense of comparison of these early stage results that Petra's putting up to what you were saying about the effectiveness of some of the machine learning applied to static.
Yeah, I mean, our experience, like I said before, if you just take a pretty good set of malicious files, even from VirusTotal, that the static analysis capabilities of those of the next-gen engines, I don't know, it looks like they put in a lot of marketing dollars. And and I had some peers, Gartner analysts, that also agree with me to see the same results. It seems to me that there's a heavy reliance on the real-time scanning components of those solutions, on the EDR components, and the static analysis component is very weak. it's also very rigid. So if there is some abnormality in the file format, or it just isn't as expected, it doesn't work. Some of the products are a bit better, like on MS Office and PDF, and other ones are better on portable executables. But that's it's just that's our finding, and it's been very consistent.
Right. Thank you.
Well, I think again they're like meant for different purpose, right? So from the beginning, let's say what used to be EDR, the entire purpose there was supposed to have like a super lightweight agent, because before the concept was like the endpoint security product you had on your machine was consuming 300% of your CPU, and all your memory, disk, whatever you had, they would eat it all, right? And the idea was that they're gonna provide like a super lightweight agent that's a sensor, that's not even like a detection mechanism on that one. And then I started bringing some intelligence on that sensor as well, but that was mostly commanded by like a command and control center in their cloud, right? So again, they took that small piece into like a static analysis component. And I'm not gonna say they're, I know, the best or the worst, but at the same time, it's a matter of like, that wasn't necessarily the focus, right? It wasn't meant for that. So it's not necessarily like apples to apples. If you're comparing like detection on the endpoint, like how it behaves on the endpoint one-to-one, that's totally different discussion.
Got it. Okay.
I'll give another example of the like the static detection by some of the AI tools. So if you would like run a MS Office document and convert it to a PDF, right? If you reconstruct it with a CDR engine and then feed that to your common AI-based detection tool, it won't be able. Some of the products out there just won't be able to parse the file. Send them a file that was generated by an invoicing system, right? So it won't be able to parse the file. Send them a digitally signed PDF document. You get failure rates for the next gen static analysis. Right? Some of these issues, when we submitted files to the vendors, they were able to post a new, new math models and improve those issues. Sometimes not. Yeah, a lot of marketing dollars that go into it. That's my feeling.
I can't believe I'm the devil's advocate on this one, Oren, but I think you're talking like a very specific vendor. Wasn't necessarily my experience with the ones that we have in our solution. But again, I'm not. I don't think that I'm trying to like push them like as amazing or something like that. But they bring some value, right? But again, to your point, like it's very limited. Like I'm getting into myself. I'm not sure if you guys hear me okay, but what I'm trying to say is that it's not gonna have. It's way less file type support than actually CDR by far, right? Like some of them support like 3, 4 file types. Some of them are gonna go and say, we're the best, you're gonna pay me for each file type individually, this much, and it's like, it's not that great either, right? Okay, maybe 2 vendors that I think you're talking about, but never mind.
Yeah, I feel like I need to move the conversation on a bit from there.
Yeah.
Yeah, I mean, just check who has offline math models that support more than just P's, and then you'll reach the, I think the 2 vendors that.
Yeah.
There are more.
There was one other question I wanted to ask, and that's about, given this started out as a bake-off, what are people's views about applying the 3 fundamental different types of technologies we've talked about to a couple of different use cases, those being files at rest and files in transit? Is there any particular pros and cons that we haven't touched on that people think are worth mentioning?
What when applying the different analysis techniques to the file?
Yeah. Yeah. So the fact that it's in transit or it's at rest make one approach much more attractive than others.
So, I think that this comes back to, returns to the different, you know, usages that we had in the previous conversations, that there are limits when you can disarm a file. There are limits to how harshly you can disarm a file. So when those limits exist, my approach is then to try to combine other supportive technologies for those use cases.
Mm-hmm.
You know, so if you can only partially disarm a file, then you should do some pre-filtering beforehand, either before or after, etc. So I believe in a synergy of the tools because that's real life,
Yeah.
and because CDR technologies, because of their capability to disassemble the file, can be more effective also in the scanning phase of it.
Got it. Okay. Anybody else got observations or comments about applicability for at-rest versus in-transit files?
Yes, I did. Sorry, Burke, Paul, I didn't quite answer the in rest or in transit, but you know, it applies to both scenarios.
Got it. Yeah.
Oh,
I think there are a lot of parameters that's defining what should be applicable or not, right? There are use cases where, I don't know, maybe you want the result in, I don't know, a minute, 2 minutes, 5 minutes is good enough. So you can actually add a way bigger analysis pipeline, right? Yeah. Or you want something in, I don't know, 1 second, or you need something in 50 milliseconds, right? Yeah. And based on that, you define, okay, what's the analysis flow, which files are going to be processed how, which are going to be, I don't know, offloaded, if any, things like that, right? So it's quite diverse. Like, yes, we are being deployed heavily in line, right? Because at the end of the day, I don't know, that's how you prevent, right? Not when it's too late. But at the same time, it's a matter of like even data at rest, right? Like even for that one, there might be some parameters. Speed is always a concern, and throughput, right? Like how fast are you able to deliver the result? And what's the result? How, I don't know, if there's anything else that can be optimized and things like that.
But with the data at rest, the performance or the time it takes to process the files is less critical, because by definition the data is already there, right? And you know, and you're looking at, you know, I think so there's some use cases that you know is worth considering. Is, for example, what happens with companies post-compromise when they really shouldn't trust a lot of the files that are left behind, right? Because you know that, you know, a bad actor was in play. You know that some files got compromised. You now have large data sets and large data stores that contain files that potentially are malicious because you're not able to detect every single file change. You know, there's an interesting argument to say if you need to move these files all from one place to the other, then you know, then you can actually apply these technologies to it.
I think that both should. I think it should be both. And I was thinking also another type of use case would be, you know, if you sent something through email or through, you know, some file sharing, that would also be something you'd want to consider. So it's kind of a thing you want to be able to, I guess, do it both ways. And I think if you're doing it in transit, then doing it at rest is going to be, I mean, a little bit more redundant.
Well, depends, right? Because again, there are separate use cases to some level, right? Yes, you can put it in transit again because that's what we're aiming for, right? That's where prevention comes into play. The example I heard with there was an, I don't know, your organization got breached and you want to transfer the files and so on. Yes, we had some of those new customers coming like, okay, I need this to be transferred, how I can sanitize, but those for me seem like one-offs, right? Like those are not like the main market and want to go after all the breached organizations just to use my technology to move data across, right? But I have like quite a few customers that, I don't know, have like some large storage. Like I have customers that are processing like petabyte a week or something like that, right? That are even like rescanning their storage and so on. So even for those ones, like time is sensitive, right? Network traffic is sensitive. It's a matter for, let's say, even if it is data at rest, but if it's like a storage device where it's being configured to process the files only when someone touches the file, when they try to like retrieve the file and so on, that's still important. That's almost like it's in transit, even though it's being seen as data at rest and so on. Right?
Yeah, I
That's
get
what I'm
that.
saying.
I wasn't thinking about. Yeah, I know. Items on a device aren't necessarily whitelisted because they're already there. Yeah, gotcha.
Okay. Well, that was really the last topic I had that I wanted to bring up. Is there anything anybody else wants to raise, as we've still got a little bit more time?
From listening to everyone's conversation on the three different methods, it sounds like there's no clear-cut use cases where one displaces the other. Seems to always be a combination of using all the different technologies in a kind of security kind of stack. Or are there some use cases where CDR or antivirus or sandbox could displace one of the others? Or is it always going to be a combination of all three and other new age detection things coming into play?
Well, I think I'm definitely biased, and I talked a lot about that one, so maybe I influenced everybody that we need all of them and so on. But again, it's a matter of, for me, in general, when we're talking to customers, again, since we have the technologies, right, we're providing that end-to-end analysis solution, even whatever we have in our portfolio that makes sense for that particular use case, right? So we have a lot more modules, let's say, not just CDR and multi-scanning, like vulnerability detection and things like that. So depending again on the use case, what the file types are trying to transfer, how they're being used, what's the response time, things like that, right? We recommend whatever makes sense in that use case. That's why I'm saying that in general, for us, it's not like, here's a technology, go and figure out, right? Like I offer you CDR and that's it. It's about like what we have in our portfolio, in our stack, and let's put the solution together.
No, I understand that. And I think we historically always positioned ourselves as part of a stack, and not as displacing any existing layer in a security chain. But again, with CDR being as not well known in the industry, it's hard to convince and educate people to add another layer to already an existing stack without displacing. It's adding more money to their budget to add in something else. And I was just wondering if there are some scenarios and strategies where you can replace something in a stack rather than adding to it. We've not gone down that route yet, but it's just it's an interesting proposal, I think.
I think rip and replace, it's always challenging. And second, if it's a more emerging technology or concept, let's say, it's even harder to go and pitch that one, right? Until they're gonna have a true market confirmation, or like a way larger market adoption, right? For them and to replace their FireEye email security or their Proofpoint or whatever, right? Just with CDR, I think that will be a bit of a long conversation. It's easier for them to add it than actually replace it entirely, right? Because if there's no clear confirmation from the market that this is the way to go, that like kind of 40-50% of all the email deployments are using CDR, right? They're gonna be like, okay, still my job is on the line. Still I know. What if, right? So those are always gonna be like questions. So I think just relying on the fact, or like kind of try to go and replace entirely the email security, the first layer if you want, that will be a bit of a big topic. And more than that, like there's a lot more functionality, anti-spam, anti-phishing, things like that CDR doesn't really cover necessarily, right?
So a follow-up question then on that topic. Thank you, Luke. Do you think customers would be more interested in solutions that contained all three types of technology? Or do you think they're looking to buy separate best-of-breed layers put into their stack? What do you think is the more attractive proposition to security buyers?
I'd say probably all three, but the honest truth is you have to start somewhere. So if you get one thing down and expand it from there, it's probably the best option as far as actually being able to accomplish it.
Okay.
So I think there are not a lot of examples of, like, let's say, large organization that adopted CDR as well. I'm talking like cybersecurity vendors that are offering it as part of their email security CDR. Probably the largest one by far is Checkpoint. Have that module that I don't think that they push it that hard. It's just like a way for them to tick a box. Probably they saw Gartner recommended that one to replace Sandboxes, reducing the load. Let's say they OEM someone and put something small there and so on, right? But again, they're not pushing it probably because it's not necessarily that technology, but it's also the fact that they don't focus on it, right? So from that perspective, again, it's a matter of should be pushed, replaced, how is that going to work, right? So even let's say OPSWAT tomorrow is going to come with like a first line email security full bundle with everything else, not just CDR, multi-scanning, with anti-phishing, anti-spam, and so on, right? Again, you're going to go head to head, or like we're going to go head to head with Proofpoint and people that in my Gartner Magic wanted to be like leaders, and they own 80% of the market, of the market share, right? So there's that branding as well. It's not just about technology. Yes, most of the times if they go in POC, and this was kind of like our experience in the past, whenever we go into a POC, kind of like win the deal, right? So they appreciated the technology, but at the same time, it is a little bit harder for them to convince someone that, hey, OPSWAT, probably you haven't heard about OPSWAT comparing to Proofpoint, but let's go with OPSWAT for end-to-end email security. I think now with, let's say, Office 365 offering some lightweight security functionalities and so on, I know, even what used to be traditional first layer kind of like moves into the second layer, so it's going to be more competition on that one. But I think there's still, I don't know, a couple of years left for that to actually happen.
Yeah.
One question. Do you know those cases where, you know, you basically have a file go through your multiple engines and ends up on the CDR on the other side, so it's sanitized, and then, like you mentioned, the file, you know, is now picked up a couple of days later or a week later as malicious, which I actually think is the poster child case study for the value of CDR, right? Because then you can really say that you are protecting against unknown threats at the moment in time. Do you have data to support that? So we have some, which I actually want us to publish a lot more, but because I think that can help the industry quite a lot, right? Because it's almost fact-based information, right? Here's a file that was delivered safely to a customer that actually, you know, in retrospect, a week later, we now know it's malicious, right?
Yep.
Do you guys have data sets for that, or? Sorry.
Yeah, we do have examples, Management Cloud and Management.com. I have to search for them. I know that, let's say, at some point we did the exercise and found a couple, let's say like 5 that were no AVs detected at the beginning, and then they started picking up. But we have a lot of the ones that are flagged by like 1 or 2 engines, and then the rest are picking up as well, right? It's also a matter of like, when do we see the sample, right? Because if we're seeing it through the malware sharing program and a vendor sees it first, writes the signature, and then shares it with everybody else, right? Then I'm going to be able to pick it up as like 1, 2 vendors flagging this malicious as well when I scan. But I do have some examples as well where none of the vendors flag this malicious.
Yeah, and that's ones that I think would be good if as even collaborate and share, right? Because those use cases are, you know, almost like, you know, a massive validation of the power of CDR, right?
DPA. So part of the malware sharing program, we need to sign a DPA to be able to share samples and so on. So yeah. Other than that, shouldn't be a problem.
Yeah, cool.
Okay.
Or if you don't want the sample, you just want like the link to show, I know, the results and so on. That's easier, yeah. The scanning is free.
Okay.
That shouldn't be a problem.
Yeah. Cool.
So actually, one of, you know, maybe just on the top of collaboration, right? I know that we talk about the test use cases, which I think is a great one. It would be good if we can find a couple of topics that we can almost post stuff together, you know, and actually I think we had a good thread on the definition of CDR. So I guess, you know, again, like we represent a good chunk of the CDR industry, right? we can help to define it a bit better, right? We can help to raise the awareness and work together on those areas of synergies where it's about gaining the understanding of how it works. So let's see. And I guess maybe just on the final thing, like, I think clearly this has been a great success, right? I think this is, for me, my main objective for this is to make sure that we can kind of come together at the forum and start to kickstart this process. So, I think it would be good if we can meet again in a couple of months or something, right? And don't lose this thread. So there's a Slack channel that we can use on the summit. If you guys want to join, that would be great. Or because we can use that as a common ground while we find maybe another CDR, maybe specific area. But it'll be good to think about the next sessions and I think this forum, which is, stuff is recorded, we share it, everything is Creative Commons and open source between us. I think it's a good level, right? Because we make sure that nothing gets shared is proprietary. We can all collaborate. We know where the line is, and allows us to kind of grow the industry. And I think it would be actually good to start to get some customers or some users joining in and going, hey, this is quite interesting, and have direct access to us, right? In a more friendly way, and then we let the market pick up which solution they want.
I think that would be first, the last part of this will be a hard sell, at least internally. Tell them, hey, I want to invite all my customers to meet all my competitors. Necessarily, but
yeah, I wasn't saying that. I think I'm thinking more of as we grow the market, right? It's almost like the new generation of customers. Yeah, not your existing ones. I agree with you, right? But the new generation of customers who, to be fair, I think appreciate this, right? I definitely feel that especially on the security industry, there's definitely an analogy that happens when you hit an industry and everything is cloak and daggers and you almost have to sign an NDA to even see the product and everything is so painful, right? I feel that we as an industry, if we play the openness game, if we play the collaboration game, if we play the transparency game, I think we'll find that there's a lot of security professionals and security teams, will embrace us, right? Because we're just going to be smoother and simpler than others.
Look, one of the things that I see missing is some like independent industry benchmarking, like NSS Labs or something like that, to show that CDR works. I've had discussions with several vendors like these to do like private evaluations. They're all saying, oh, we have CDR on our roadmap. Or if you just press them, then you actually find out that all they really test is keys. And when you ask them about, productivity documents, oh, we don't do that. It's too hard to create test samples for that. So that's also something that can be considered, just to show like some independent test body to show that this works well.
So a third party or an independent test body would actually do the field good then. That might be something that might be interesting.
It might be. I think the challenge is
think about and pick up and run.
Yeah, I see the challenge being that there's only a relatively small number of well-known, recognized bodies in the kind of anti-malware testing arena.
Specifically for CDR, but I mean,
yeah,
you
but
pick
CDR
up a few
doesn't
other
fit the mold for most of them, right? I mean, I know George, you mentioned AMTSO, but I feel like a lot of the standards they apply, you can't really evaluate CDR on the same basis as they apply.
Yeah. I mean, yeah, Paul, I completely agree. Like I had discussions with, I think it was NSS Lab, about their testing methodology, and like pressing them, how do all these vendors get all these percentages? And you find out they test just binaries. They don't ask them, what about weaponized content? Like, no, we don't do that. It's
yeah. So I feel like we need to get together maybe to apply combined pressure to see what we can do to get them to rethink how they do some of that testing to make it compatible with how CDR does things.
Okay, but again, the tests that they're doing it's mostly on the endpoint, right? That's item number one. Number two is what EMSO is trying to push is for them to document properly their methodology. And that's like, that was the biggest, I don't know, pain point for the vendors, for the AV vendors, to push the testers to have a proper methodology in place and to send comments. If you give, I know, vendor A the chance to configure his product, all the vendors should have the same chance. All the vendors should reply within 3 days or things like that. So like that is the testing methodology that they're defining, right? Now, when it comes to like testing in general, the organizations part of EMSO testing organizations, they're gonna go and apply similar methodology, not necessarily like sample set and so on, like similar methodology for this kind of tests as well. They're like private and public tests as well. We can talk in some other time, but again, I'm part of that group. I know quite a few of those organizations pretty well as well. So if you guys want to move in that direction at some point, I'm pretty sure we can find the right people to help us out.
I think the point is it's trying to get together and look for the common ground between our different companies as to how we make CDR a more visible, viable proposition to more people, right? And if we have to get that through, how, because the first thing gets asked, if you say, well, we can help you protect against malware, malicious files, they go to those things and say, well, what's your test results, right? And how do we address that as an industry?
Right, but I feel like those two are not necessarily separate, but I mean, in any sales engagement, people will always ask like, okay, and how do you compare with X or Y? Like I'm looking at these 2 or 3 vendors, like why you do it, it's unique. Even like when you're talking with the analysts, like it's exactly the same discussion, right? Yeah. So to have like that benchmark test or like comparison test and so on, that for me is more towards almost like sales enablement. It's not like market education per se. Again, from OPSA perspective, we've been open like from like always, ever since I joined like almost 6 years ago. So from day one, we've been open, like all technologies available, free consumption on right in the cloud, limited, I think like 50 files a day or something like that, but still people can use it, right? So we're not hiding anything from that perspective. But at the same time, it's a matter of like, I don't know, yes, I think there are frustrations like how they're POCing things, how, I don't know, each of us with our own API, each of us with our own way. So like at the end of the day, the prospects are kind of like, okay, I don't have the bandwidth to test 15 different vendors. I'm gonna select 2 or 3, and maybe I'm gonna spend the time only to like integrate with 2 of them, test it out and so on, right? So those kind of things that, yes, this comparison benchmark might help, let's say, speeding things up and like, okay, I'm gonna go in POC with these 2 or 3 vendors. Let me see, this is what I need, 1, 2, 3, let's do it. But other than that, I'm not sure if that's gonna help pushing as a technology the market forward.
Yeah, I mean,
sorry, I love to talk. It's kind of
that's fine. Yeah, I mean, we know we deal with. I know of at least one big US government agency who did quite a lot of testing on different CDR solutions, right? And the irony was, in the end, the test measurement they were putting on us, they were determined by applying static and dynamic analysis, and saying that's the measure of efficacy, right? Which it yielded some interesting results for us, because we had a few cases where they said, well, you didn't clean that file because it's static analysis still says it's dangerous. But when they put it in a detonation chamber, dynamic analysis returned absolutely nothing. And one of the things we found with CDR is sometimes, you know, if you think about the document being a bomb, we're taking out the fuse, but actually the payload is still in there, but it's inert. And that can sometimes trigger, you know, positive responses somewhat falsely from a static analysis point of view. So there are some interesting specific challenges that you come up with in comparing the different technologies.
Yeah, well, I'm not allowed to confirm or deny anything about that exercise, but I would say this, unfortunately it wasn't published and it's still kind of like in a pending state and so on, right? Yeah. But that for me was like an interesting test, or like one of the only tests that was, again, it's not public yet, where multiple vendors, not that many, but a few of the vendors were tested and there were some interesting results, I would say that.
Yeah, or maybe we can work together on some shared definition of evaluation criteria or something like that. So I think there's plenty of areas we can continue to discuss.
CDR, TSO, something like that.
Yeah.
All right, gentlemen, I think this has been a really good session. Thanks for jumping in, and especially, I know George, you started at 6.
Yeah.
For us.
But I'm fresh now.
Yeah.
Exactly, man. That's impressive. And then Grant, Owen, great, jumping in, and all the Glasswall crowds that also, chip in, and 10 o'clock at night in the UK. And I hope that this is the beginning of a great set of collaboration, right? So, thanks for everybody, and I think it's been some really great sessions.
Thank you very much. Thanks you all. Pleasure meeting you. And Petra, awesome research. Really, that's really the way to go. So it was great. So thank you. Thank you very much.
Oh, thank you.
Thank you.
I really, really enjoyed this discussion. It was great. It was really good. It's such a sparkling discussion. Thank you.
Yeah. Okay. Well, we'll bring